So the next challenge we have is, let's say we want to take this graph-oriented database and we want to search it fast. We want to process queries against that graph-oriented data as fast as possible. So let's use a highly parallel supercomputer to operate on this stuff really fast. You now encounter another problem. If you're doing a scientific computation on one of Cray's scientific computing supercomputers, suppose you're simulating the flow over an airplane wing. On a parallel computer, it's fairly easy to divide up the work of the simulation between processors. Here I'm drawing an arrow and I'm drawing a line to indicate that what's in between each black line is the aerodynamic simulation that's going to go on each processor. So out here where there's less turbulence, the one processor might handle more than in the middle here where there's a lot going on. What's nice about parallel computation on a scientific problem is that the physics generally dictates a way to divide up the data so that most of the time each processor is working on its own data contained in its own memory. So most of the time each processor will be doing the simulation of the aerodynamics within its portion of the data, and then occasionally it'll exchange information on the boundaries with its nearest neighbors. So most of the time the computation can go on internal to a processor in its own memory. However, if you look at a big directed graph, suppose we've got a database that's made up in the structure of a gigantic directed graph, there's no obvious way to divide up this data so that most of the processing that any given processor does is mostly internal to it. It's got to be reaching out all over the network, going to other processors' memory to get the data for the very next step it's going to do. None of this nice behavior that you get in the scientific computation case. So on the most conventional machines, they are unable to perform well on this kind of a data structure because they can't divide it up in such a way that they don't have to communicate with each other except infrequently. That's where the specialized system of the Eureka database system comes into play. My name is David Mazzell. I'm a senior technical project lead at Yark Data, and this has been a Eureka moment.